All right, we're back, and as promised in this video, we are going to implement relative tokens in the cd command. This is probably going to be pretty straightforward because we only need to support these guys and collapse them into an absolute path. So let's just actually do this. So in the do find entry here, we need to collapse the relative tokens in this path and create a new path out of it. So from the tokens thing, we have separated the elements in the absolute path by the directory separators. So in the case that we also include dot and dot dot, the tokens value is going to contain those parts as well. But we need to eliminate them in the tokens list and create another value which does not have the dot and dot dot in it. So let's just create a step, an intermediate step like 1.5, which is to eliminate or collapse relative tokens. And this is going to behave in the following fashion. So if you take a second to think about it, if I have a list which says A, then dot, that means I'm navigating to /A. /A will be converted to the list of tokens per this expression. Okay, so the tokens list is going to be this guy, which has the element A and the element dot. Well, the dot thing doesn't actually do anything, so it's worth cutting it out. So this will transform to the list of just A, just for this example. Again, if I have A, then B, and then dot, and then another dot, all the dots will go away. So this is the absolute path /A/B/dot/dot, which will transform to this list. Then the dots will not have any effect. Okay, so this list will transform to the list of A and B. So the dots themselves stand alone. They're not going to have any effect on the absolute path. On the other hand, if I say /A/dot dot, then this dot dot will redirect me to the parent of this A folder. So this transforms to the list A and dot dot per this expression as before. And now what I need to do is to collapse these tokens into the empty list, because the dot dot will then move to the parent of A, so that I don't need to navigate to A and then to its parent again. I just need to collapse it. Okay, let's get a more elaborate example. So if I have /A/B/dot dot, then this will get transformed into A, B, and dot dot, and the dot dot will collapse B because I am navigating to /A/B and then to the parent of B, which is A, right? So this will transform to just the list A. Hopefully this makes sense, right? Because the dot dot navigates to the parent. I hope you understand where what I'm aiming at here. So the logic for collapsing relative tokens is going to be pretty much exemplified in these couple of examples. So the dot doesn't actually have any effect, so we can just cut it out, and the dot dot will just eliminate the first non-dot element in the list just before it. So if the dot dot is next to a non-dot dot element, these things will just collapse. Okay. So let's create a small method which will call collapse. Let's say collapse relative tokens. Okay, and from a path, which is a list of string, we'll return a list of string. Okay, but say we want to follow the functional programming principles very, very closely, then we would like this function to be tail recursive. But if we want this function to be tail recursive, we need to supply some sort of an accumulator to store the result of our computation. So let's call this result, which is the accumulator there that we were talking about. So the result is going to be a list of string. And let's leave this unimplemented for now. Okay. And let's just use it right below. So val, let's say new tokens, which is another list of string, that will be the result of that function's application. So we're going to say collapse relative tokens out of the original tokens, and in our case a simple list. In this list we are going to store the result of the computation of this function, which is going to be tail recursive. So let's go ahead and implement that. Now, as with any recursive function, we are going to start with the edge case, which is, in our case, if path is empty, then we are going to return the result. Otherwise, if. Now it becomes interesting. Now, if the dot equals path head, then this dot will not be taken into account. So we might just skip it. So just call collapse relative tokens with path tail, that is, we're skipping path head, and the same result. Okay. Otherwise, if the dot dot equals path head, now this case is more interesting, because if I'm, for example, if I'm in a root folder and I'm doing a dot dot, or if I say /a/b and then dot dot /dot dot /dot dot /dot dot, I might attempt to navigate upwards of the root folder, and I should not allow that. So if the result is already empty, that's what the equivalent condition of navigating upwards in the root folder is, then I'm just going to return null. And if this guy returns null, then I'm going to throw an exception or handle that later. Okay, but this is obviously not desirable. Otherwise, just collapse relative tokens out of path tail and result tail, because we're prepending elements to the result as we go along, and this will happen here in this last branch. So we're going to say else. So if neither dot nor dot dot is path head, then we're just going to append that to result. So we're going to collapse relative tokens out of path tail, and we're going to append result with path head. So we're going to say result, column plus, path head. Let's go through some examples to validate that this function works well. So, creating a little comment here. So, if I say, let's consider the plain case, /a/b. The /a/b will get transformed into the list a and b per this expression, right? So this will take care to separate the path. So /a/b will get transformed into the list a and b. And collapse relative tokens on this one will say path is empty, no, otherwise is dot or dot dot equal to path head, no. So we are hitting collapse relative tokens out of path tail and result append path head. So result, which is list, append path head. Right? So result is list plus a, which is a. Okay? And then we calling collapse relative tokens out of path tail, which is b. And the result is that guy. Again, is path empty? No. Then is dot or dot dot equal to path head? No. Then we run collapse relative tokens out of the empty list. So path tail out of the empty list at this stage, and the result is a, the previous result, appended with b, right? Which is the list a and b. Good. Now path is empty. Cool, we have it, and then we return result, which is this guy. And then this will get propagated above, and collapse relative tokens out of this guy will return the same guy. Okay, so the normal case without dots, without dot dots, is going to return what we expect. Now, dots are pretty easy to validate that they work correctly because we're just skipping them. So that's all well and good. But what happens if I say /a/dot dot? So the list is a and dot dot. And let's follow the same logic again. So path is empty. No, then is dot or dot dot equal to path head, which is a, no, and then we return collapse relative tokens with path tail, which is dot dot. And the result is the empty list plus or appended with a, which is the list composed of the element a. Now, path is empty. No, then is dot or dot dot equal to path head? In this case, it is. Result is not empty, so we're going to return collapse relative tokens of path tail, which is the empty list, and result tail, which is the empty list. And because result path is empty at the following call, this will return the empty list, which is what we want. Okay. Let's try one more complicated example, and then we're calling it a day. So let's say we have /a/b/dot dot, and that will give us the list composed of a, b, and dot dot. And again, path is empty. Path is empty. No, we're going to return CRT of b and dot dot, and the result is going to be the list composed of the element A. Again, path is empty, no, and then we are going to return collapse relative tokens out of ... and A and B, because B is appended to the end, A and B. Okay, then is path empty? No, and the ... in this case is equal to path head. So the result being non-empty, we're calling the same CRT with path tail, which is in this case empty, and we're getting result tail, which is A. Oh, this is actually wrong. The result tail is actually B in this case, which is not what we want. We want it to collapse B, not A. So instead of result tail, we should say result init. Init is a method which returns the list less the first element, not the last element. Now let's try a more complicated case. I think we were almost making a mistake here. So if we have /a/b/c/... we follow the same procedure. So finally we're getting to CRT of the ... in ABC, because this case worked well with ABC. And then path is empty? No. And what does the code say? ... equals path head. So we return collapse relative tokens with the empty path and result init, which is A and B. So we're collapsing the last element of the result. Okay, this is what we want. So make sure you run this code in your head, or preferably on paper, like I did right now, because we were almost making a mistake here. Okay, so now we made sure that this function works well. I'm gonna feel free and delete this comment, but if you have any doubts about this implementation, just take a moment or two to test it out for yourself, and then feel free to continue with this video. Alright, so let me stop this, and we don't really need to do anything else, because we're already calling the collapse relative tokens. We just need to use the new tokens value here in find entry helper, and we should, in theory, already support dot and dot dot in our cd command. So let's run the application and see what happens. So running. Okay, we're doing mkdir a, and then let's cd a. And then let's try cd ... and pwd. And voila, we are in the root folder. If we do cd a/a/dot/a, we should then, in theory, be in the same A folder. So A, the same, then parent, which is root, and then A. pwd. And lo and behold, we're in the A folder. Cool, so this should work well. Let's create another directory, and then cd to that, and then cd ... Okay, and we are in the root folder. Let's try going above the root folder. We're probably going to crash. Right, because of the null pointer exception. We should probably take that into account. Let's add the check here right below new tokens, because this function may return null. So if new tokens is null, then just return null and let cd deal with that. So destination directory is null. So do find entry will return null if this new tokens is null, which is good. Otherwise, find entry helper with the new tokens. Okay, let's move this comment above. No, just like that. Okay, and let's try running the application again, and we should probably be good right now. Okay, so no such directory. We're not crashing the entire application. Cool. We should be good to close this video because we now support relative paths, absolute paths, and relative tokens such as dot and dot dot in the awesome cd command. I'm going to be seeing you in the next video very shortly, where we will start to implement the remove command.